Hello, hello. Let us look at a typical question here. So we've got a phasor diagram, and then the phasor diagram has currents. So we do have a current here, and then a current here. We do have also a current there, I total, and a current IB. Okay. Now let us look at how to solve these questions that come up with this question there. So you've got the currents and you are required to calculate ZA. You're also required to calculate ZB and ZC. So you've got 2 marks for each. So let us remember. Let's start with question 2. Let's start with 2.3.1. ZA. Typically ZA is given as the voltage divided by the current. So the voltage divided by the current is that IA is 10 amps. So it's 10 amps. And remember, it's horizontal about the x-axis. So that means the angle there, theta, is at 0 degrees. So we have 10 at 0 degrees. And then the supply is also at 0 degrees. That means we're going to have 100 at an angle of 0 there, divided by 10 at an angle of 0, which gives us 10 at an angle of 0 amps. Not amps, sorry. It's not amps. That should be in ohms. Okay, that is ZA. Let's go to question 2.3.1. So question 2.3.1. Question 2.3.2 is ZB. So when you look at ZB, we follow suit. V supply over the current running through there. So we have 100 at an angle of 0, all dividing with, okay, so IB is there. So let's look at the angles that we are having. So IB is following that angle. That means IB is 13,426 at an angle of negative 147.5. So remember, in mathematics, when we take angles in the positive side, we go into anti-clockwise. If they are negative, we go anti-clockwise. So this angle is actually in the negative clockwise direction. So that will give us 13,426 at an angle of negative 147.5. This is going to give us what? An answer of, let me calculate it, 7.4, let's make it 48, at an angle of 147.5 degrees. So that's ZB. Then let's look at question 2.3.3. Let us look at ZC. I'm sure you're only noticing there's a pattern. So VS over IC. So we have 100 at an angle of 0 divided by 5.614 at an angle of 63.3. So that gives us 17.813 at an angle of negative 63.3. Okay, so now the question can also continue. For example, I would add question 2.3.4. Now calculate, let's calculate x. Let's see which one will be better. Let's calculate xb, and then let's calculate xc. Okay, so remember, for this to happen, we need to convert zb into the form a plus jb, which is a polar rectangular form. So in our case, we need to convert it back to a rectangular form. So let's quickly calculate it. So we want the rectangular form for this one, 7,448, and then which has an angle of 147.5. So that gives me negative 6,282 with a positive j of 4.002. So now remember, this is the r plus j xl minus xc, xl minus xc. So now we're going to take this value, which is our xb. Therefore xb is equals to j 4.002. xc will follow suit. We take zc, convert it to rectangular form. So let's convert the rectangular form of 17.813 angle negative 63.3. That gives me 8.004, and then minus j 15.91. Let's say 914. So therefore xc is minus j 15.914. And we can continue and ask you, you know that xc 1 over 2 pi fc, then xl is 2 pi fl. So all you need to remember is that If it's positive, what does it say on the, let me just go down a little bit. What does it tell us on our we have XL and we have XC, we have R there. So on the phasor diagram, this is a phasor diagram reactances. Okay, so reactances as a phasor diagram along those lines. So the question can also continue, okay, calculate what is C, what is X, what is L as well. Okay, I hope you find this very, very interesting. Thank you.